Hello. Now we start the answers of the mock test numerical practical semester 6. Question 1. Compute the value of fx at x equal to 1.20 plus r plus 1 by 400 x equal to 1.40 plus r minus 10 by 400 by suitable interpolation formula from the following table. This clearly these nodes are not equispaced because this difference is this from x0 to x1 is this 0.4, but from 1.26 to 1.20 is 0.6. So not equispaced arguments. So we can use either Lagrange interpolation or divide difference interpolation. And this is the Lagrange interpolation. First with this float x dimension, y dimension 200, d dimension 200, sum ow xx dimension 10, integral variable in I k j r. Enter the value of r, the last digit of your roll number is scan r. Enter the total number of interpolating points. Here the total number of interpolating points here 8. This 1 2 3 4 5 6 7 8. So total number of interpolating points is 8. The interpolating points xi, this x0, x1, x2, x7, and the values of fxi, that is yi, is equal to y0 to y7, and the values of xi for which the interpolation is required, that is we say xx0 is 1.20 plus r plus 1 by 400, and xx1 equal to 1.43 plus r minus 10 by whole divided by 400. Calculation, the required values of fx for k equal to 0, k less than equal to 1, semicolon k plus plus, for I equal to 0, I less than n, this I plus plus, and di equal to 1 initial value, for j equal to 0, j less than n, j plus plus. If j equals to 1, I, di equal to di star xxk minus xi, and else di equal to di star bracket xi minus xj. And if di equals to 0, printf this y equal to y at the point x equal to yi. That means di equals to 0 means xkk equal to xi. This is the particular case when xkk, that is the say x00, x0, this value equal to say x2, identical, say x2 equal to x0 for our some certain r values. Then we write this. And then go to the next step. Next step means this here. Actually, this is the next increment of k, that is k equal to 1. Next values of xx. Otherwise, if not equal to 0, w equal to 1 for I equal to 0, I less than n, I plus plus, w equal to w star bracket x xk minus xi, sum equal to initial sum equal to 0, or I equal to 0, I less than n, I plus plus, sum equal to sum plus yi divided by di. If di equal to 0, so this result is absurd. Sum equal to w star sum printf y at the point and x, this xx equal to sum of the value, and this that next step. Yes, and the post you can write return 0 or not. So this we compile, no errors, and compile and run this program. Here the enter the value of r, this say 9, enter enter the total number of interpolating points, here 8. So required value of fx is this, y 1.2250 equal to 0.3281472921, and y 1.4275 equal to 0.3715046048. Next question, compute the values of the following integral correct to 5 decimal place. This Euler's rule using 19 coordinates. This integration 10 degree to 40 degree cos square a plus x whole divided by root over of hyperbolic cos ax plus whole root over of a plus sine hyperbolic ax dx, where a equal to 6 plus r by 16. So question 2 is Euler's rules. First, to define constant float y equal to 3.1415925, and this function is this, this float f, this float f products function is float function, and products product. You can omit this float s, so you can write directly return this. So omit this line, return this cos px square, cos square px whole divided by square root of hyperbolic cos px plus square root of p plus hyperbolic px. Here float variable a, b, h, p, x is dimension 50 and sum integer variable n, I, r. Printf, enter the value of r, scan r. Printf, enter the lower limit a in degree, that is 10 degree here. Scanf, a. Printf, enter the upper limit b in degree, that is 40 degree here. And up is the some statement, this up colon. Print this, enter the number of ordinates, number of ordinates here 19, giving number of ordinates is 19 here. So number of subintervals is this 18, and this 18 must be a multiple of 6 for Euler's rule. This n equal to n minus 1. So new value of n is the number of subintervals. Printf, the number of subintervals is, if n not divisible by 6, modulo division 6 not equal to 0, that is not divisible by 6, then re-enter the ordinates. Ordinates means this 19, we put here ordinates, number of ordinates 19. If you put number of ordinates 20, then we again this re-enter the number of ordinates, so that this number of subintervals must be a multiple of 6. And go to up. So up is this step, up colon, this print, enter the new number of ordinates. Next, conversion degree to radian of the integrating limits. So a equal to pi into a whole divided by 180, b equal to pi into b whole divided by 180. This radian, a and b, new value of a and b is radian, and p equal to, given that r plus 6 by 60, it is given in the question, and a is the step length, length of the subinterval. This h equal to b minus a by n, initial sum equal to 0, and integer k equal to 1. Actually we write here k, no here k. This is the k is actually integer k equal to 1. This for I equal to 0, I less than equal to n minus 6, I equal to I plus 6. So this from this for k equal to 1, number of subintervals, that is from 0 to 6 and 6 to 12 and 12 to 18 is the k equal to 1. For k equal to 1, I equal to 0 to 6, and k equal to 2, I equal to 6, 7 to 12, and so on. Plot x0, x1, x2, x3, x4, x5, x6, x0, x1, x2, x3, x4, x5, x6, sum equal to sum plus 3 into h by 10 f of x0p plus 5 into fx1p plus 5 fx2p into plus 6 into fx3p plus f of x4p and plus 5 into f of x5p plus f of x6p, and increment of k equal to k plus 1. Then the required value of the integration is this sum and this new line. First we compile, no error, so run for enter the value of r, say r equal to 5. Enter the lower limit in degree, here 10. Enter the upper limit b in degree, here 40. Enter the number of orders, here 19. So number of subintervals 18, and the required value of the integration is 0.22758. Next question, question 3, find a positive root. Actually, this is the smallest positive root. This is the smallest positive root. Sorry, I cannot write here. Find a smallest positive. Find the smallest positive root of the following equation correct to 5 decimal places by regular Cauchy method. This log x square plus k to the base k minus 7x bracket 6.3 minus x e to the power 1 plus e to the power minus x plus k square equal to 0, equal to 5.9 plus r plus 1 by 2. The question 3 is the regular Cauchy method. First we define the function float function f, and the arguments are float x and float k, and return log x square plus k divided by log x. Here log means the base e. So log x square plus k to the base k, that means log of x square plus k divided by log of k. Both are to the base e, minus 7x into 6.3 minus x bracket into exponential e to the power 1 plus e to the power minus x bracket close plus k square. Yes. Main program is float a, b, x1, x2, h, k. This error term, actually this error term, this tolerance level, we said here this 1.0 is this 10 to the power minus 8, that is 0.1, 2, 3, 4, 5, 6, 7, 7 not 1. An integer variable r, printf enter the value of r, the last digit of roll number, scanf r, t equal to 5.9 plus bracket r plus 1 bracket close divided by 2.0. That is the giving value of giving the value of k is given in the question. The step some colon printf enter the endpoints of the initial interval ab, scanf ab. So it is very important to correctly choose the value of ab. If you choose a equal to here a equal to 0 and b equal to 1 is the appropriate choice. If you choose a equal to 2 or b equal to 3, then again re-enter the initial interval. A equal to 0, b equal to 1 is the correct choice here. Uh, if f of ak into f of bk greater than 0, printf change the initial interval ab. Go to the step. So again go to the step here. Enter the re-enter the endpoints ab. Else h equal to b minus a into absolute value of f or divided by absolute value of f ak plus absolute value of f bk, x1 equal to a plus h, and do if f ak into f x1 k is less than 0, b equal to x1, else a equal to x1, and x2 equal to x1, and h equal to b minus a into absolute value of ak divided by absolute value of ak plus absolute value of bk. This is the full bracket denominator, sorry, x1 equal to a plus h. This do loop closed here, this do while loop, while absolute value of x2 minus x1 is greater than error term. Error term is this 0.701. This then again again this do loop, enter the do loop again, and print the required smallest positive root is x1. First we compile, no error here. Next compile and run, and this is the value of, enter the value of r, say 0. Enter the endpoints of the initial interval a b. We put here 0 and next put here 2. Required smallest positive root is, the required was 0.15193. Next question, question 4. The compute the dominant eigenpair of the following matrix by power method, elements being correct to 6 significant figures. This is the 4 by 4 matrix, and C equal to R plus 1 by 10. Question 4, power method. This power method include stdio.h, include math.h, define size is 200. So this integer variable I, j, n, k, r, fruit variable a, size into size, two-dimensional variable a, x, one-dimensional variable x size, zz is a one-dimensional variable size, nz size, e size, ct, z max, z mean, e max. This enter the order of the matrix n, here n equal to 4. Enter the value of r, the last digit of the roll number, and c equal to r plus 1 whole divided by 10. This in the question. This matrix is a, here is also given. This the question is a11, a12, up to a44, and the initial non-zero column matrix x is x1 equal to 1, x2 equal to 0, x3 equal to 0, x4 equal to 0. To print the matrix A, printf for I loop, and for j loop, this print this aij. This is the matrix A matrix. Print the initial column matrix x. This print this 10.6 xi, printf calculation. This printf lambda x1, lambda x2, lambda into x1, lambda into x2, lambda into x3 is, and k is the number of iteration, k equal to 0, and do k equal to k plus 1, printf is k. For I equal to 1, I less than equal to n, I plus plus, and zi equal to 0. And for j equal to 1, this j less than equal to n, j plus plus, and this zi equal to zi plus aij star xj in zi equal to zi, and store z in nz for rearranging the elements of z, printf nzi. To arrange the elements of ax in ascending order, this for I equal to 1, I less than equal to n plus I, or j equal to I plus 1, j less than equal to n plus j. If nzi greater than nzj, t equal to nzi equal to nzj, nzj equal to t, is interchange variable by bubble sort method, and z minimum equal to nz1 and z max equal to nzn, and choose the numerically largest element ax. If absolute value of z minimum is greater than absolute value of z maximum, then z max equal to the z min, and printf the z max. Divide each element ax by z max for I equal to 1 to n, zi equal to zi by z max, and print this zi. Check the tolerance level for I equal to 1 to n, ei equal to 0, ei equal to absolute value of absolute zi minus absolute value of xi, and emax equal to u1 for I equal to 2, I less than equal to n, I plus plus. If ei is greater than emax, emax equal to ui, or I equal to 1, I less than equal to n, I plus plus, xi equal to zi. While this do while loop, emax is greater than 0.0001, and print the numerically largest eigenvalue and the corresponding eigenvector, and this printf is return 0. First we compile this program, the difficult program, no error here. Next, run. Enter the order of the matrix. So here 4, enter the value of R, say 8. Here the matrix A is this, initially is matrix 1 0 0 0, and this table for this matrix for R equal to 8, the numerically largest eigenvalue is 27.283188, and the corresponding eigenvector is this minus 0.762971, 1.0, minus 0.538043, 0.261700. And the question 5 is RK4 method, conjugate method, dy dx equal to this is the at initially x equal to 0, y equal to 4 plus r minus 8 by 20. This function, first to define the function float f, float x, float y, return 1 plus e to the power minus x square into cos xy whole divided by 2 in plus x square y square, x square y plus y square log x. This log x means the to the base e. In program, float variable x0, y0, k1, k2, k3, k4, k, y, xh, xn, integer variable r, enter the last digit of the serial number r, and this x0 equal to 0.0 is, or you can write this, enter the initial interval, scan this, and y0 it is given that 4 plus or minus 8 by 20. This is the final value of x, that is xn equal to 1. The scaling is this, see, h is equal to 0.1. So we choose here h is equal to 0.1. Say from 0 to 1, we divide these 10 intervals, 10 sub intervals. This printf, and this table k1 is this h into f, k2 equal to h into f of x plus h by 2, y plus k by 2, k3 equal to h into f of x plus h by 2, y plus k by 2, k2 by 2, k4 equal to h plus f of x plus h, y plus k3, k equal to k1 plus 2k2 plus 2k3 plus k4 whole divided by 6, y equal to y plus k, and x equal to x plus h. And printf is return 0, and it's no error. Run this program. I entered the last digit of your serial number, 3. So x equal to this 0 for y equal to 3.75, x equal to 0.1, y equal to 3.745649, and so on. When x equal to 1 is y equal to 4.322061. Thank you. This completes the mock test. Thank you for watching this video.